Let's talk about doing a circuit that is in series. When a circuit's in series, you have one path that the current travels along, and you have multiple resistors that current may pass through. In this case, we're going to use one resistor that is 10 ohms, one resistor that is 20 ohms, and one resistor that is 30 ohms. They can be any variation in relationship to each other. We'll also use a 12-volt battery. The first thing we always need to figure out is to calculate what the total resistance is. And in the situation of a circuit that's in series, RT is going to be equal to R1 plus R2 plus R3. If you have more than that, you would just keep adding them in. If you only have two, you would just add those together. In our situation, we'll take our total resistance is equal to 10 ohms plus 20 ohms plus 30 ohms. 30 plus 20 is 50, plus 10, 60 ohms. The second thing that you'll do, once you have your total resistance, you'll need to find your total current. Now, in a circuit that is in series, the current is the same throughout the whole circuit. So once you calculate it once, it will be the same in each one of these resistors. So in order to do that, you'll use the equation that I equals V over R. And in this case, you have a 12 volts here, and you're going to divide it by your total resistance of 60 ohms. Well, 12 divided by 60 is going to give you 0.2, and it is your current, and current is measured in amps. Once you have that, once you have the current, that tells you that your current here is 0.2 amps, here is 0.2 amps, here is 0.2 amps. Over here, 0.2 amps, over here, 0.2 amps, all of them. So the third thing you can do is calculate the voltage drop in each resistor. Well, for the 10 ohm resistor, you'll use the equation that V equals IR. As we've said before, the current is 0.2 amps, and the resistance is 10 ohms. 0.2 times 10 gives us 2. We're measuring voltage, so volts. We do the same thing for 20 ohms. V equals IR, still 0.2 amps, this time times 20 ohms. 0.2 times 20 gives us 4 volts. Again, we'll do it for 30 ohms. V equals IR, still 0.2 amps, this time 30 ohms. 0.2 times 30 gives us 6 volts. Now to double check what we actually have happening here, we're going to take, and 2 plus 4 is 6, plus another 6 equals 12 volts, which is what we have on our battery up here. The last thing that we would do, and sometimes you need to, sometimes you don't, if it's asking about power, would be to calculate the power. Again, we'll do that for the 10 ohm resistor, the 20 ohm resistor, and the 30 ohm resistor. And in each case, P equals IV. And in each case, the current is the same. 0.2 amps, 0.2 amps, 0.2 amps. The voltage will vary based on what we have up here. So for our 10 ohm resistor, we'll use 2 volts. For our 20 ohm resistor, we'll use 4 volts. And for our 30 ohm resistor, you will use 6 volts, the voltages that we have up here. Well, 0.2 times 2 equals 0.4 watts. 0.2 times 4, 0.8 watts. And 0.2 times 6, 1.2 watts. So when you've gone through each part, you have completed and solved your circuit. So what does this look like? Well, if you have a single bulb and send some current through it, it gets really, really bright because the full voltage drops in that bulb. Here, the voltage is split between the two bulbs, and because you have a higher resistance, you have lower current, so the bulbs are not as bright. As we continue adding bulbs, and
light them up, you'll see that the circles that are created by the light bulb, the light from there, they're getting smaller. With 4 bulbs, it's less bright, and then with 5 bulbs, it will continue to be even less. And the more bulbs you put on, the more that the power starts to decrease. If we speed it up so you can see them all next to each other, it's a little bit more apparent. So we have them. You can see that they're getting less bright every time, and you can keep adding and